So, the microphone is working well. Good afternoon to everyone. Here is the Bayesciamella team. I'm Natascia, and she is Claudia. So we are going to introduce you to the solution we are proposing for solving this challenge. So, next slide. Okay, so here is the challenge, the identification of dark ecological corridors. Apologies for the delay. So let me introduce briefly to the context, even if already well explained it before. So basically, artificial light at night has been identified as one of the major burden of human activity on environment. And recent estimates has shown that 24% increase in light pollution in the UK between 1993 and 2000. And you see, you can understand it is a real environmental emergency. And in particular, it is an emergency for all these animals, all these species that have a nocturnal activities, in particular bats. Indeed, from literature, we know that depending on the species of bats, up to 90% of their activities can be compromised by light pollution. So the city of Bristol.
Yeah, you need to just click and wait.
I should think before, yeah. So the city of Bristol is engaged in solving this solution, in particular launching the button lighting research project from Bristol University. And we want to help with this challenge, the Bristol Council, to solve this problem, looking for dark ecological corridors to connect the main bats locations. This is a solution that we are proposing for the city of Bristol, but we think that it is highly generalizable to other locations. So the solution the Bayesciamella team is proposing is increasing in complexity step by step. So first of all, we analyzed the location of where bats were spotted, and as you should see here from the video, the bats' locations change a lot over years. So we thought, okay, first of all, let's try to identify the main bats' locations. And we did it through simple clustering solutions, doing it by the X-means algorithm. By this way, we could identify the main points that we want to connect to create these dark corridors. The X-means, the advantage of using X-means with respect to the better-known K-means is that we don't have to make assumptions on the number of clusters, also because we know this is very depending on the time, so we just prefer to do not make assumptions and let the X-means algorithm work to find the best solution. So after finding the main bats location, we said, okay, now we have to find a way to connect these points. And as the resolution of the data we were given was 1 kilometer square because of privacy issues, we basically tessellated Bristol into squares of 1 kilometer size. And the idea was to, once given two pair of points, to find the best cost, the least cost path, draw the extra algorithm. But then the point was, okay, we have to find a smart way to define the cost function. Because, okay, we want to save bat, but also we want to take into account the safety of human, of course. We cannot switch all the light off. That's why the cost function that we built is taking into account not only the number of bats and the number of moths that are the main source of feed for bats, but also the number of lights already on in that particular place and the number of crimes happening on a particular box of the map and the number of traffic accidents happening on that place. And this is a solution for a static problem. But, okay, we also have to take into account that bats maybe are moving over time, so we cannot find a static solution. So this is the reason why we implemented 2 Markov chain models. Basically, with these Markov chain models, we are modeling the probability of bats moving from one side to the map to another side of the map. Indeed, the state vector provides, in some way, the most preferred locations for bats. So by this way, we could integrate the static solution with the least cost path with the bats' behaviors. And now I'll leave the stage to my colleague Claudia.
Thank you, Natascia.
Ready, press, Claudia.
For the last phase, we produced a model trying to include multiple interaction between bats, moths, and environment. In practice, we implemented an agent-based model to achieve overall optimal lighting configuration. Why agent-based model? Agent-based models are naturally very suitable for ecological problems, since they include multiple entities interacting with each other, but also with the ecosystem. In the meanwhile, we can see an example of our agent-based model simulation. In particular, we included, of course, bats agents, moth, but also urban areas and green areas and lamps. Lamps are supposed to have 3 different possible status. The first one is completely on, then completely off, and alpha way, trying to represent reduced lights. Here you can see a path to product. Of course, everything starts with data, collection and cleaning. Then the doc cost function and model should be defined and validated, and possibly further improved considering domain knowledge. In this way, the product is ready to be integrated with the Bristol Center Management System of Lights. We believe that our solution is really cost-effective, since our model do not require intensive training, since are deterministic or probabilistic. And then we can save time and resources. To wrap up, our product is able to predict the location most likely to be visited by bats, and then to identify which areas are more adapted to become dark corridors or to reduce lighting, of course, putting an eye on public security. We know our solution is based on simple assumption and on probabilistic approaches, but can be easily generalized, and further improvements can be done considering expertise, for example, of ethology. To conclude, an example could be considering that moths are more attracted by blue or white lights, or for example, that bats prefer to go to hunt during sunset. In this way, for example, the models can comprehend different attributes for lamps, for example, the colors or the lux ratio to postpone the light on. This concludes our presentation.
For your lovely presentation, and now you'll have 15 minutes to answer the questions. I also have a couple here from Gitty, but maybe we'll start someone from the jury panel, whoever wants to go first.
One, two. Well, first of all, thank you so much for your presentation. Okay, thank you so much. I didn't see in the presentation any impact metrics to evaluate the success of the work. Did you use them? And if so, could you explain what kind of impact metrics did you use and what results did you achieve?
Yeah, actually the idea was to use as an impact matrix the same length of the same cost of the path, because basically we can model the the cost of switching a light on or off with the same cost function. We built a cost function with our poor knowledge about I mean, we tried to read a lot about in literature, but of course the domain knowledge is really important in this case. So we try to model this cost function, accounting for bats, moths, street lights, criminality, so public safety, so criminality and accidents. But of course, this is something that should be modeled embedding the domain knowledge. So our idea is that with the cost function we already have an impact measurement. I mean, if we are minimizing that cost function at a certain level, we should kind of be able or evaluate the quality of the product.
Thank you so much.
Thank you.
So first, thanks a lot for the presentation. Congratulations also for the amazing work you did. I have several questions, but I will start with just one. You explained that you have several parameters in your model, like bats, traffic accident, crimes, etc. And I was just wondering, what is your trade-off? I mean, which parameters are the most important? For example, if in an area you see that you have a lot of crimes, so maybe that it would be nice to keep some lightings, but in the meantime that it could also be an interesting black corridor for bats. Like, what will be the output of a model in such a situation?
Are you going to answer, Claudia?
If you want to answer.
Okay. So as I was saying, we basically define a score for each of this point. Like a score for a bat ranging from 0 to 10, a score for moths going from 0 to 10, so and so on, in order to have comparable scores. Because I cannot say, okay, here I have 3 accidents, here I have 3 crimes, how to compare. So we did it based on the considering the distribution of the data, so looking at the histogram and basically normalizing these values on a 0-10 range. And then weighting these single scores, choosing the weights, I mean, giving our interpretation of what should be more important or not. But again, this is something that before put this solution in production, as we were explaining, the model has to be validated, embedding domain knowledge.
Thank you.
Hello, so thanks for the presentation and for the work. So I have a question related to this previous question. So the way you weight the different factors is static, or does it change, say, with the time of day? I would say, for example, it's less serious to turn off a street light at 3 or 4 a.m. than it is at 10 p.m. So do you keep it fixed or do you change it?
Okay, thank you for the question. For now, the solution only consider constant cost function. Our intention at the beginning was, of course, to have a variable and depending on time cost, but we do not have too many time series data, so we prefer to have a custom one.
Just another quick, more technical question. So you say that you estimate a Markov chain to kind of model the transitions of the bats from one of the clusters to the other.
Yes.
From what data do you estimate the parameters of that Markov chain? Do you have tracking data that tells you which bats go where?
No. Again, we didn't have bats reports at so specific granularity. So what we could do was to build the probability as the inverse of the cost function, basically. So we modeled the probability of a bat to move like an inverse of the cost function. But actually, in the probability of the Markov chain models, the bats are not accounting for criminality and traffic accidents, of course.
Okay, thank you.
Thank you very much for your presentation. I just had a question about the nature of some of the data you used. Can you explain what crime data you used to inform this?
Yeah, there is an open Bristol data portal from which we could extract the information about criminality and traffic accidents. About criminality, there were early reported data by district. So basically, we approximated the number of crimes in a square as the number of crimes of the district actually. So we had the information at the district level, not at a 1 kilometer square level. While for the traffic accidents, we had the precise location of the accident, where the accident was occurring. So we were able actually to be more precise on that level.
Thank you.
I have a question from Gitty.
Okay.
First, she compliments you on the crime perspective and for including it in your model. And then the question is that not all the bats are the same. So for example, a swan is not a house sparrow, but they are both birds. How could you solve this inside your project?
Okay, for the simple solution, we do not consider differences in bats, but this is why we said that we need domain knowledge, collaborating with real experts in the field to understand what are the differences and how can be included in our model. For example, considering times where bats go hunting, or for example, in which period of the year, for example, they move to reproduce, and all these considerations.
Okay.
If I may.
Yeah.
Okay. Can you hear me?
You just talk. It will.
Okay. If I may add something to that, the good point is that with all the models you saw today, it is quite easy to add variables and to add them with the right weight and to balance all together. You don't need to retrain neural networks. You don't need to start all over again with studying cross probabilities, because all the models you saw today, they on their own accounts of all the dependents. So it's quite easy to complicate the models as much as we want, integrating domain knowledge and all this stuff. So yeah, that's the whole point.
Thank you. Further questions? Yeah.
I was also wondering, like, so you say that your model is quite evolutive, and how could we, for example, create a kind of feedback loop, you know, to see? So you talked about agent-based modeling, to see how effective is really your model. Like, imagine we are running the model, and how could we see if it's really in adequation with what's happening in the city?
Maybe we have to consider, of course, let's say a score that focuses on bats, happiness, and the other which represents the number of lights that were switched off. For example, we know that we have to maximize the lamps that remains on for public security reason. These are the two metrics we should consider during the simulation and during the possible real application of the product.
One question more from my side. So obviously this is a prototype, okay, but how much time do you estimate and how much effort do you estimate to have this prototype into a solution? And what do you need besides the validation from the experts?
So basically, from a data collection point of view, I think with this, I mean, we modeled the problem on the data available. So we could keep using this product on with the same way of collecting data. We don't have to change the way of collecting data with this model. So one can keep collecting data as long as he wants, but basically we could already use the data we have available. The main time-consuming part probably is the validation of the model with a knowledge-based assumption. I mean, with help me, Claudia.
With the experts, I think we mean.
Yeah, I got it.
Yeah, the validation point of view. Of course, it depends on the granularity you want to study the problem, because if you are considering early data, you have to wait 1 year to see if your solution is working in 1 year. But if you want your model to build paths in 1 month, you have to wait a couple of months to see, okay, this solution is working well or not. This month, yes, okay, then I can change this parameter and see what happens. It is a simulation, but you should have a simulation of the simulation to assess the quality of the simulation. And of course,
I got it. Thanks so much. Grazie.
Another part we can work on could be like a way of visualizing the output of the final models to the end user, because maybe here you need to use Python and to know statistics to understand the output of the models and to visualize, to have a complete picture of the problem. Some time may be spent in making it available to the end user, which maybe knows nothing about statistics, and try to find a way of making it understandable to a bigger, like, to all the people, basically, which are interested in the problem.
Thank you.
Yeah, so just one more sort of detailed question. I like the details. So when you define the cost to then apply Dijkstra's algorithm to get the shortest path on this grid, 1 kilometer grid that you built or that is built somehow, does this grid and the cost take into account what's on the ground? If it's a park or a street or there's a high building or a short building, is that taken into account, or it's just a regular grid?
no. I mean, no. We didn't take into account the urban planning. Was it the question? No.
Yeah, sort of. I don't know if bats have a tendency to fly over, say, taller buildings or not, or if they try to stay near trees. Is there any information about that?
No, actually, in the agent-based model, we took into account if a location was urban or not. Actually, we did it thinking about we should not switch the light off in a urban area, but it's true. It also affects the way buffs are moving. Actually. Okay. Yes.
Okay. Thank you.
Maybe one last one from Gitty, just then quickly. Have you, then just kind of more of a clarification, have you looked only at horseshoe bats, or did you look at any other bats? Because some bats eat moths, but some other eats, for example, mosquitoes. So maybe if you could clarify that as well.
No, in this solution, we consider all the bats are the same, and that they have all the same diets.
Mm-hmm. Okay. And then how would you need to extend? So how would you extend? And maybe I'll follow. She didn't write this, but maybe I'll follow it up, since I'm pretty sure this is what she wants to ask. Then how would you, for example, extend it to different types of bats with different foods? Is it that you introduce new agents, or?
Yes, maybe, of course, this can be generalized, adding, for example, to the bat agent the attributes I like moth, or I like, I don't know, mosquitoes, and also include in the models these other possible resources for the agent.
Yes, that's one of the advantages of this agent-based model. That's really simple to make changes, and so if one bat decides to eat whatever else, someone in his life is allowed.
Okay, perfect. So we're in the last 30 seconds. I don't think there is, unless if there's a quick yes/no question from the jury. No? Otherwise, thank you very much. A big round of applause for Petrella.